Good afternoon, everybody. Uh, I am Revati Krishna and working here as a BIM application engineer. Our today's session is based on the modeling of steel structures. Okay, so this is about BIMLABS. BIMLABS is situated in Kerala, southern state of India, and we are also a partner of Autodesk Training and member in Green Building Council. And these are the services which provided by BIMLABS. And here you can see the social media contacts of BIMLABS. These are the certificates which BIMLABS have. BIMLABS have a membership in Green Building House IGBC, and okay. Then the corporate office is situated in Kazhakoottam, Thiruvananthapuram, and we have branch offices at the Statue, Cochin, Kozhikode, and uh, Dubai. We have a franchise in Kollam also. And these are the services which BIMLabs provides. First one is the finishing school. Here we will train students, and we have a project session which is BIM Studio, and we have a bridge session where we will give placements to the students. Okay, these three are the different services of BIMLabs, and I already said that we are also an authorized training center and a partner in Autodesk and Bentley, and a member of IGBC and India BIM Association. Okay. So today we are discussing about the steel structural modeling. Steel structural modeling in Revit. So structural modeler represents the framework for a system, and this framework is the place where all other components exist. As you can see in the frame, this is a steel structural model which is modeled using Revit software. So these are another two models which we modeled using Revit software. So I'll show you how to model a steel structure using Revit. Okay. So I just opened the Revit software, and there is a tab steel which was introduced in 2019. Okay, 2019. So I'm selecting the template for that one. So click on the new portion. From here we can browse our template. I'm selecting the structural analysis default metric because all the modeling part of the steel we will using structural portion, and other portions detailing we will use steel template. Okay, so I'm selecting the structural analysis default metric. Open. Okay. Okay, here we have the steel tab. As you can see, here only we will have the modification panels, that is parametric cuts, modifiers, fabrication elements, and connection. All the modeling we will done using the structure tab. Okay, so first I have to create. I am going to model a warehouse. For that, I'm first setting the unit UN in and I'm changing the unit of length to meters. Okay, and then go to the structure tab, and here first I have to draw the grid lines. So we'll have a datum panel over here, and from here we can select the grid, or otherwise type GR on the keyboard. We will get the grid lines, and using the draw panel we will have different four options. First one is the line, and I'm using the pick line option. So first I have to draw a single line, so I'm drawing a single line over here. Okay, then I am going to pick the pick line option, and here we can give an offset value. So I'm giving a 10-meter offset value, and then like this you can draw the grid lines. This is the vertical grid line. So for then I have to draw the horizontal grid lines, change the offset to 0 and draw the horizontal grid lines. As you can see Here with the grid number is 5 and here it is 6. I want to change, rename this one. So select that portion and rename it to A. Then again go to the structure tab. From there select the grid and using the pick line option, I'm giving an offset of 10 meter again and drawing the grid lines over there. Okay, so now I'm draw the grid lines in level 2. You can go any of the elevation. Here we have two different levels, level 1 and level 2. Now I am in the level 2 option. So then I have to place the column. I already said that all the modeling parts we are using the structure tab. Only modification or detailing we will use the steel tab. Okay, so from the structure tab I'm selecting the column option. Okay, in column option there are different types of columns. Universal columns, we will get different types of different sizes. If we need more sizes, here we have an option lot family. Go to that portion. From here US and structural column. Here we have the option structural column. Select the material. I'm having a steel material. Select that material and then select the particular column section you want. I'm selecting the universal column option here. Then click on the open. We'll have different types of size over here. So select any of the size we need. So I'm selecting this one and click on the OK. So now the size of 3656 by 405 divided by 551 universal column. So I'm placing the column over here at this portion. Okay. Now I am changing the detail level to fine. Now you can see the uh, correct shape of that column I section. And before drawing the column, if I am selecting the column option, we have two different options. Here I'm just give the depth and connection to the level 1. So as you can see in the 3D view, our column will be like this. Okay, then again go to the plan view and again I'm going to draw the beams in over here. So select the beam. Also we can load the beam family also from here. So I'm drawing the beam midpoint to midpoint. Okay, then we have to split the beam to ഇങ്ങനെ തന്നെ BIMLAB എടുക്കുക. Okay, then we have to split the beam for creating the apex hole connection. So for that I'm going to the modify tab. You'll get the option split beam, split elements. Select that option and here we have 5 meter, so 10 meter. So I'm cutting the beam in the mid portion. Okay, okay, then go to any of the elevation. You can see the columns and beams are over there. So I'm draw the beam from start point to this to end point this. So select all the first beams and this is the starting point of the beam and this is the end point of beam. So I'm giving an end level offset a value, enter. So the position of beam will be like this. Select the other option, value to 1. So you will get these kind of supports. Then go to the trim or extend tool and using this we can reduce the gap between two views. Okay, Okay, next part is okay. So then we are going to place the connections over here. For that, go into the steel tab. Here we will have a panel of connection. So first time clicking the connection, we only get the one type connection, generic connection. For loading the connection, again go to the steel tab, and here we have an option connection setting. Click on that option. We have different type of connections over there. Select all and load all the connections to the project. Now we have different type of connection. As general, in beam end-to-end connection, we will give apex hinge connection. Okay, so I'm going to select the apex hinge connection. You can clicking the apex hinge connection, you will get the selection order and the profile of apex hinge connection. I'm just selecting the apex hinge connection and selecting the beam, pressing the control and press enter. So as you can see, there the connection is like this. Do the realistic view. Okay, so here we will get the apex phone connection. For modifying this connection, select the connection and go to the edit type. Okay, and first we have to create a duplicate. So I'm just duplicating this as apex hinge AH. Okay, then go to the modify parameter, and go to the edit option. This is our connection. First is the general end plate. Okay, so first is the thickness of this plate. All the data will be denoted here using numbers. So first one is the thickness of the plate. So now the thickness is very small value. I'm giving a value of 0.05. Enter. As you can see, I'm giving a smaller value 0.05. The thickness of the beam is increased to 0.05 value, and the next one is the erection tolerance. This is the gap between these two plates. Okay, so I'm giving a value of 0.01. Enter. So there have an erection tolerance. Then the third one is the projection in top region and bottom region. Here we don't have a projection. If you want to add any projection over there, you can add the projection value on top and bottom. So you can modify the connection as per your requirement. Then go to the hinge option. This one is the hinge option. So you can give the length from inner plate to the face. You can see the value. First one is the length to inner plate. This is the horizontal distance between this point to this point. Okay, you can give any value over there as per your requirement. And the next one is the height from rafter to bottom. This is the height from rafter to bottom. This height, as per this is the height from the rafter to bottom. So you can give a value over there. And next one is the hinge 2. Here it is disabled because we will tick is on the same section as rafter. You can untick these two. Same for both sides. You can edit the hinge 2 option also. Okay, then go for the bolt option. Here we are using 20 bolt. You can also edit the bolt diameter as per your requirement, and also bolt type. Here we have different types of bolt. So you can select as per your requirement. Okay, so horizontal distance between bolt is here minute value. That's why it is represented as 0. You can give any value over here as per your requirement, and number per one side. Here number per one side is 1. If you want to increase the number on one side, you can enter a value over here also. As you can see in the figure, all the parameters are denoted using numbers. From here you can identify the parameter and change the value. Okay, then go to the bolt group. We have two different groups, group 1 and group 2. Group 1 is the vertical group and group 2 is the horizontal one, and on either side. If you want to change the start distance, intermediate distance, you can enter the value over here and modify this bolt. Okay, then go to the stiffener option. Here this is the stiffener part, this one. uh, Here the haunch plate, stiffener 1 have full size. If you want to reduce to half, you can reduce it to half. In haunch 2 also. Okay, as per your requirement, you can edit the all the parts of this connection. Then going for the weld option, here we not only have bolted connection, but also we have the welded connection too. So we can enter the type of different weld and weld thickness. This is the weld thickness. So the welding numbers denoted the weld options. First one is the end plated web. This is the weld in end plate web. You can edit that one in, you can change the weld type and also the thickness of the weld. Okay, last one is the special option. Here we can add additional plates to the connection, reinforcing plates, galvanizing holes, central marks, beam stiffness. We can add all these additional features if it is required. Okay, so this is how we can edit our connection. Then clicking the OK option, then here also OK. So all the changes we made in our connection will be visible over here. Now, as you can see, the connection is modified. Like this, you can modify your connection type. Okay. Then here I'm giving a connection of, for the column beam connection, I'm giving a connection of, selecting the connection again. There are many different types of connections. I'm selecting the clip angle connection. Okay. The clip angle connection for the column beam connection. First you have to select the, I'm selecting the clip angle connection, then select the column and pressing control select the beam and click the enter option. So you can see there is a clip angle connection. You can also modify this connection to select the connection and go to the edit type. From there you have to, first you have to create a duplicate, then you can modify the connection. Again clicking enter, you will get the same connection. So here also I'm giving the clip angle connection. Select the column and click on the beam, press enter. Okay, so this is the clip angle connection. Okay, and I'm selecting the apex hinge connection because we didn't. Okay, apex hinge connection and clicking these two beams, enter. Again click enter, we'll get the same connection. Enter. Okay, so we just joined all these beams and columns, and here in a single column and two beam we are using the double brace connection. So I'm going to use the brace angle double. Okay, bracing splice angle double, this kind of connection. Okay, so I'm just selecting that one, selecting first column, again the beams, enter. Again enter. First select the column and the beams, enter. Again select enter, select the column and the other two beams. Okay, now we just connected all the beams and columns. Then we have to use the base plate connection for the foundation. So for that I'm going to the level 1. From here we can go to the level 1 and again go to the structure tab. Here in foundation panel we can select a different type of foundation. I'm selecting the isolated foundation and not do, and selecting the rectangular foundation and placing it over here. Simply click on the columns, it will be there. So as you can see, now we have the foundations over there. Then go to the steel tab, select the connection option. For the foundation I'm choosing the base plate connection. Select the column and click enter. So there we have the base plate option. So we can't see the connection inside the foundation. So select the foundation and right click. We'll get an option override graphics view. From here I'm going to the by category option. If it is by element, only the modification will affect only this element. I'm going to the category option and changing the transparency to a value. Apply. Okay. Now you can see okay, and again click on enter. We'll get the same connection. Click on the column, enter, again enter. Okay, so we just completed the first part of our frame warehouse. Next we have to copy all this. So go to any level over here. I'm just going to the level 2 and select the whole elements, and also in level 1 press Ctrl, select the other element too. Now our element is completely selected. Go to any plan view and from here select the copy option, and I'm selecting this as the reference point and paste the elements at the intersection of grid points. Okay, now we just aligned all the frames in our warehouse. Then we have to create the roof. So in structure tab we don't have a roof element, so we have to go to the architecture tab for the roof element. From here we will get the roof option. Select the roof option and go to the level 2. I'm just going to the level 2, and from here I'm using a rectangular option. Otherwise you can use any of this drawing element. So I'm using the rectangular portion and starting from here I'm drawing the roof. Okay, just a second. Before drawing the roof we have to measure the inclination in our roof. So go to any of the section views. From here we have to measure the inclination. Okay, go to the annotate tab. From here I am using the angular dimension. From this point to this point it is 31.31. The angular dimension is 31.31. This is the inclination in our roof. Then go to the level 2, and from the structure tab I'm selecting the roof option. Using any of the drawing element I'm selecting the rectangle option. You can draw the roof over there and then press escape and select the any of the roof portion. Here you will get the define slope option. Click on that one. Then we will get a slope over here. Edit this to 11.31. Similarly select the other part and click on the define slope option. Edit the slope value to 11.31. Enter, and then finish mode. Click on the finish option. Now we have the roof, but the roof is not visible in our structural option. So because we select the roof from the architecture panel, so go to the visibility graphics. From here also you can go to the visibility graphics or enter VG in the keyboard. From here select the roof option, tick the roof part and apply. Okay, now we have the roof over there. We have to reduce the transparency, increase the transparency of roof also. So select the roof and go to the override graphics view, and by category mode I'm just increasing the transparency. Apply. Okay. Okay, Then next one is the after creating roof, we have to create the purlins. For that, we are using a option beam system. Okay, so beam system is used for creating more than two numbers of a group of beams inside in a closed boundary. Okay, so here we have a closed boundary, and for creating more than two or three number of beams, we have to use the beam system option. The short key for beam system is BS. Okay, so I am selecting the roof bottom as the boundary for beam system. For that, first we have to select the plane. Okay, here we have to select the plane. So from the set option, I'm selecting the pick a plane option and in level 2. Okay, pick a plane. Okay, so I'm selecting this plane, here this plane, and again go to the beam system option. Here we have a, we'll get the drawing panel. Using the pick point option, I'm selecting this part of the roof. Okay, I already said that the only we can create the beam system in closed boundary, but here it is not closed. So using the trim or extend option, we can select the make it a boundary close. Okay, so I'm just selecting this one. Okay, after that, next one is the direction of beam. If you want the beam direction in this portion, you can go to the beam direction option and select uh, the boundary line, or otherwise in this direction you can select the beam boundary here, so the beams will be aligned in this direction. So I want to align my beams in this direction. I'm selecting the beam direction over here and then click on the finish mode. Okay, so you will get the beams over there. Now we have three numbers of beam. If you want to edit the beam system, click on the beam system, and you will get the property of beam system. From here you can edit the fixed distance, fixed number. If you want 6 numbers of beams, you can simply enter 6 and enter. So there we have 6 numbers of beam. Okay, so you can edit the beam system also. Okay, now I only need 3 numbers of beam, and I'm going to the south elevation. Here you can see the beams are merged with the rafter. The purlins are merged with the rafter. So we have to move the purlins. For that, first we have to measure the distance of this one. So the distance is 0, because in unit the precision is 0. So I'm going to select the unit in distance mm. Here I'm selecting the decimal value to 2 decimal places. In rounding this to 2 decimal places. Okay, then measure the value. It is 0.3. The distance is 0.3 between over there. So 0.3. So select the roof over there and change the roof offset value to 0.3. Okay, similar like this, we can create the beam system over here. For that, we are using the mirror option. Okay, so go to the select the beam system, and from here we'll get the mirror by pick axis and mirror by draw axis. I'm using the mirror by draw axis, and you can draw the axis over here. I'm drawing the axis here, so you will get the beam system over here. Okay, so as you can see, we just completed one part of our warehouse. Okay, I didn't give any type of connection over there, but we have to give the connection, any connection to fix the element. Okay, then select the beam systems and roof using control. We can copy the element, go to the any plan view, and clicking on the copy option. I'm using this as the reference point. We can simply copy the whole element. Okay, is it And I'm also giving bracings to this beam. So go to the structure tab. Here we have brace option. Simply click on that. We'll get the brace. If you want to load any other type of brace, I'm giving a round shaped brace. Go to the load family option, and here round bars. I'm selecting the round bars, then open. And select any size over there. I'm selecting this one. Okay. That was okay. Structural framings. Okay, I'm selecting the structure for beams and bracings. We have to select the structural framing option. From there, select the uh, steel option, and select the round bar open, and select any of the size over there. Okay. And here click on the 3D snap also. We will get the end and midpoint. From here I'm starting this from this point to this one, really a small value from this to this point. Again from this point to here, and here to here. Some gave bracings over there. The value of bracing is really small. You can choose different shape or size of the bracings. Okay. So this is how we can create a warehouse using the Revit steel model. There are different other options in steel. This is the basic how to create a Revit model using Revit structure. In steel panel, we'll get not we don't get any modeling options, but only we'll get the modifying or um, cutting options. So the first panel is used for the parametric cuts. Okay, here we'll get different type of cuts. First one is the meter cut, and we'll have two other type of meter socket flange and meter socket web, different type of cut. If you want to cut or shape any of the element, just a second, I'll show you. I'm just go to the structure tab and select a column over there and here, and also in beam. Okay, so as you can see, there is okay, as you can see, there is a column and beam, and we have to connect this one. So before connecting, we have to cut and shape this one. Okay, for that we are using the parametric cut. The first one is the meter cut option for joining the two corners of a beam. First one is the meter cut option. Okay, we can use the meter cut for joining to the corners of beam. I'm selecting the meter cut and clicking or selecting two beams by pressing Ctrl. You can just join them. Okay, here you can see that the two beams are joined. After joining this one, you can provide the apt connection over there. Okay, this is the first type of cut. And second one is the cut through or cut by. Cut through or cut by is used by similar kind, but it is using to cut the, you can use this as a trim or option too. So I'm just show you how to use that one. Go to any plan view. I'm just drawing a beam from this point to this point, and place a column to Okay, I just a second. I'll show you. Just I'm just placing columns at this point. I'm just selecting these columns and taking a copy. Okay, select the columns and I'm just taking a copy. Okay, then I'm just draw beams to connect that one. Okay, so now I have a frame section. So go to the steel tab. Here we have a cut through or cut by option. Selecting any of this, select the column and the beams. Enter. Just a second. Okay, so I'm just selecting the beam should be continuous. Now I just created the beam, splitted beam. So go to the level. Just draw the continuous beam. Okay. Then first you have to go to the steel tab and using the cut through option, select the first beam and the second one. Click on the enter option. As you can see, this portion of the beam is cut and it is joined with the column, other column and the beam. This is the miter cut. I think this is the use of miter cut. Similar like this, we have notch and a cut by. All the parametric cuts are similar, and here we have two other option: corner cut and shorten. These are using for other modifications of steel elements. Okay, so similar we'll have different type of modification in steel tab. All the modeling part is done using the structure tab. Okay, so this is how we can model different type of steels structures using rivet steel. So we can use grid intersection option if it is continuous. For the first, I'll show you. If here we have a, I'm just going to the select the plan view. Here if I want to use the or place the columns in intersection point, here we have an option at the grids option. Okay, at grid option we can singularly place all the beams or columns in the grid portion, intersection of grid points. Now I just try to copy the elements. That's why I'm simply click on the region over here. Otherwise you can use the at grid option for placing the columns in the intersection point of grids. Any other doubts? About the steel structure modeling, we can model the steel structure using other software also. There are different type of software like advanced steel, Tekla. We can use all other softwares. Now we are using the Revit steel. The structural detailing or steel structural modeling will introduced in Revit at 2019. It is a Autodesk product. Okay, so any other Q&A related to the steel structure modeling? Hello, am I audible?
Yes, yes.
Okay. If you have any doubt, you can ask. Yeah, we can provide balance a connection. If you want to provide a connection, go to the 3D model. Here we have beam end-to-end connection or beam-to-beam connection. From the steel tab, we will have the connection option. Click on that. From here, we can pick on any of the suitable connection for the purlin. So if I'm just selecting a connection for beam-to-beam connection, you can select now I just selected the clip angle skewed connection. If the connection is not proper, we'll get a warning message. Okay, so I'm just giving control, click on this, enter. So this is not a proper connection. That's why it is like this. We can use any other connection. I'm just going to the connection tab. You can use purlins top of the beam. For changing the location of purlins, first go to the elevation view. From here, we have to measure the total distance of the purlins. Okay, first using the annotate tab, here we have the option aligned. Using this one to this, we'll get 0.29. The difference is 0.29 here. Okay, that's why there will be a gap in between here. So you have to measure the value and select the roof, because we selected the bottom portion of roof as the purlin beam system plane. So the purlins will be attached to the roof bottom, and select the roof bottom. Here you will get the option base offset. Okay, base offset from, and enter the value. Now if it is 0.29, enter the value 0.29, or if it is 0.3, you can enter that value also. Okay, now it is 0.29. The base offset of roof is 0.29. Then the purlins will be in between the rafter and the roof. We can change the location or position of the purlin in between here. And then what is the next question? We have to provide a connection. So for providing connection in purlins, go to the option 3D view or any other view. Go to the steel tab. Here we'll have the connection option. From here we can select the any of the particular type. Okay, I'm selecting. Okay, here I'll get the bolting gauge option. Okay, I'm just selecting that one, clicking the first one and selecting this one and enter. So we'll just connect this 2 points. Similar like this, we can connect the this portion and to the roof. Okay. So again, go to the fun select same option. Select the this one and select the roof. Actually, I think the roof material is not similar one. That's why it is not selected. So if both the materials are same, we can connect the purlin to the roof and to the rafter also. Is it clear? Actually, this is I think you uh, this one is you are referring this as a clash. This one is the bracing point. Okay, so I think I just picked the wrong point. That's why it is from here. Uh, the connection is just second. Just adding the connection. H. Okay, actually that is not the clash. First we have to. I'm going to the structure tab and selecting the brace option. From this point to enter this point, and from here again start enter to this point. So the bracings will be below the purlins attached, which is attached to the roof rafters. Okay, above the bracing there will have the purlins. Then there will not be any clashes over there. The bracing is attached to the rafter, not to the purlins. Okay, the purlins is in between the roof and the rafter. If there is any clash, we can remodel our uh, model or redesign our model. Okay, is it clear? Z purlins. If you want to add the Z purlins, you can simply draw the purlins over there. Select the bottom portion of roof as the brace or the plane of the purlins and simply draw the purlins over there using any drawing palette. Asphalt sheet to the roof. Okay, if you want to change the material of roof to asphalt, if it is in Revit, you can change. Okay, select the roof and go to the edit type. Here we have an option edit structure. We have an option edit. From here we can change, select the material of the roof by category. Here asphalt. Here we have asphalt between roof. Simply select the asphalt between group roof. Okay. Okay. Now you can your roof material is asphalt bitumen. Similar like you can change the material of your roof. Go to the edit type. Before changing the original value, you have to create a duplicate. Okay. After that, you can go to the edit option, structure edit option, and select the material as per your requirement. Okay. Uh, exact sheet shape. Okay, we can't add direct the exact sheet shape. If you want to add the sheet shape, you have to um, load the family from somewhere. You have to load the sheet family, and you can simply like similar like we will load the families of door, window, kind of thing. You have to load the family or download the sheet family. From there you can simply put the sheet over there. Otherwise we can draw the exact shape of that material. Trying to connect the Z Perlin connection, not showing, that's why I asked it. Z Perlin connection, I think, and is that the Z Perlin connection actually, I think here, you mean this one, the bracing one, or this Perlin one? Okay, these kind of connection for the purling. This is I just applied to the purlins. Similar like this. Here I just applied the connection. If you want the other type of connection, go to the steel connection option. There we have different type of connection. Um, I think we can use this one. I'm just selecting the beam and purlin. No, it is not suitable here. I think this one is suitable one. I just, no, it is not proper one. That will get a warning message. Uh, in the beams, it's okay. Actually, I think this kind of I just gave here it is also a purlin connection bolting on gauge lines. If you want to vertical connection, you can choose any uh, other connection. Actually, I didn't get any suitable connection over here. Purlin connection. Just a second, Anna. Okay. Is it suitable? Did you mean this kind of connection? Uh, I I don't know. Do you mean this kind of connection? But we have so many different type of connection. You can use any of these connections. Okay. I think is it suitable here as a parallel connection? Is it okay? Okay. Any other doubts? Hello? Fine. Okay. Anybody have any other doubts? Hello? I think it's clear how to model a warehouse in using Revit steel, or you can model any other different shape use of steel structures using Revit steel. Here we have different options, and we can use all these parameters also. Fabrication elements, modifiers, parametrics. We only use the steel tab to modify our model. Okay, we use the structure tab to model our structure. So that's why we are selecting the structural analysis default metric. Any other doubts? Can we add U-bolt connection to the footing? Okay, I'll just I'm just changing the uh, going to the edit type. Go to the I'm just creating a duplicate as BS. Okay, then go to the modify parameter. Here we have a anchor and holes. Here we have the anchor type, changing the anchor type to, you mean J type anchor or U type anchor? U bolt connection. Uh, Hooked round J round J square. Actually, we don't have a U bolt here. We can use J or any other kind of bolt. Okay. Or otherwise, if you want to add any U-bolt, you can simply customize using the bolt panel. You can draw the bolt shape. Here we have only J and straight bolt. Okay. If you want to add any J kind of anchor, you can use J anchors. Is it fine, Jijin? Instead of beams, can we use truss work for the roof? Yeah, if you want to add truss in the roof section, you can draw the truss option. You have to draw the truss shape here. Okay. If you want to change the size, select the column option here. Here we have different type of beam, or otherwise you want go to the edit type. Here we can change the go to the edit type. You can edit the parameters over here. Otherwise, you can load the size from here. Here we have, if I'm selecting this one column, here we will get the load family option. Okay, from here you can select the go to the English US structural columns. Okay, here we have different materials. Select the steel material, and you can select any of the section. If you want a I section, universal column open. From here you have different type of the columns. You can select any of the section from here to the like. Okay, you can load the different type of section. Is it clear? Or in structure tab, here we have the truss option. Okay, we can use draw the truss portion using this one. Just simply select on that one and place the truss above the columns. One more doubt: why the slab edge is no level in the nails work? One. Actually, Jijin, I didn't understand what you wrote. Can you explain the last one? One more, why the slab edge is no in level in the NAS work? Hello? Actually, you have a session of Navis work in the upcoming weeks, so you can ask this doubt over there. They will answer you. Okay. Slabbergy is showing in the no level. Okay, you'll get answer in that session, in Navis work session. Okay. Uh, any other doubts? You can edit the model using Revit. Simply modify that one if it is not working Naviswork. Actually, I'm not familiar with Naviswork software. If you want any other doubt, you can get a session regarding that. You can simply ask them. Uh, recording, uh, yeah, I'll share the recording. How can I share the recording? Just a second. Uh, Anantu. Okay, Anantu will share the recording to you. Okay. Okay, anyone have any other doubts? Okay. I'll share the recordings. Our ആരാ? Okay, I'll check the recordings. We'll share by mail. Uh, Actually, the recording will share our marketing team. They will share you the recordings. Okay, recording will share by mail. You can just you have to share your mail ID in chat box. You'll get the recordings. Okay. Okay. Thank you. Thank you all.